Hi folks, Toby Weston here again with another video. This one is a talk I gave recently at a conference in Frankfurt where I'd been asked to talk about digital disruption and how technology is changing the enterprise. So I work for large companies and this is my day job. I also write science fiction books as a hobby, and lately I've noticed these two worlds coming together. So I thought this talk was a great opportunity to try and explore some of those ideas and put them together in a light-hearted deck. I got plenty of laughs when I delivered this, so it should be interesting. The talk I want to give is called Deep Disruption. It seems pretty obvious really that we create new technologies based upon the previous technology. But this sort of ratcheting up of our technology is leading us to some very strange places, and we have to start asking ourselves, where will it all end? But of course, if we're going to look at the end, we might as well start at the beginning. So 4 million years ago, humans created their first technology, stone tools crudely chipped, banged together to make sharp edges. And for the next 4 million years, very little changed. We see on the left crudely chipped lumps of rock, and on the right, slightly more refined lumps of rock. But this represents an incredible amount of time, and the people actually living through it, the people banging those rocks together, they wouldn't have noticed any change over their lifetime. In fact, even grandparents to grandchildren, generation after generation, the technology remained pretty much static. Even up until a few thousand years ago, it was possible for somebody to write this: "There is nothing new under the sun." In fact, for most of that time, our biology was changing quicker than our technology. So we became upright, we walked on our hind legs, freeing up our hands, our brains got bigger. But our technology remained pretty much the same. And then, just over 10,000 years ago, something changed. We invented the wheel, we invented the steam engine, we invented the iPhone, and unfortunately at the same time our brains started to get smaller again. So this is what we mean by exponential technology. We see a lot of gradually, followed by a very short amount of suddenly, where most of the change is happening. Now people have used different examples to show this. Transistors on a chip is a favourite one, of course, going back all the way to Moore's law from Gordon Moore. But also people have used the number of patents submitted to a patent office, or the amount of electricity that's used by a city. And all of these graphs tend to have a very similar shape. But one that I find very simple, very compelling, and the data is very easily obtained, is actually the number of digits of pi. People have known for thousands of years that pi is about 3. The Egyptians knew it was 3.4 something, and as time has passed, these mathematicians have slowly increased the resolution of pi. And so from prehistory all the way up until the 1500s, pi grew to about 20 decimal places, the precision of 20 decimal places. Then from the 1500s, we had the Enlightenment, we had the Renaissance, we invented the steam engine, we invented the telephone, we invented the aeroplane, and pi moved to 1,200 decimal places. And this is in the 1950s. So after taking thousands of years to get to 1,000 decimal places, between the 1950s and today, pi moved to 2.5 trillion decimal places, which is a quite astonishing number. It would take me about 30,000 years just to read the whole thing out loud. So in the same time, we landed on the moon, we invented the internet, we discovered DNA, we created artificial life forms, we built quantum computers, and I haven't checked my blogs this morning, but I could probably add another couple of world-changing technologies that have arrived since breakfast. So this is exponential change, and we're only just getting started. It's only really since about the 1970s that people even realise this is what was happening. Of course, Gordon Moore again with the famous Moore's law, but people like Vernor Vinge have been writing about this in science fiction, and Ray Kurzweil has written several books on the subject. And it's not difficult to understand why. We're using technology to create technology. The first computers were designed on paper, but pretty much now the majority of the work is done by computers on computer. So technology feels like it's getting faster because it really is. And this has some big implications. Just 30 years ago, we invented mobile phones. Smartphones are only 10 years old. Voice conversational interfaces are only a couple of years old, and they're only really getting started. Okay, so that's all pretty far out stuff, and I gave this talk at an industry conference. So what does this mean for software development? So the answer might not have been very popular. IT is going to be radically shaken up, many jobs will disappear. People do like to argue about whether technology creates or destroys jobs, but what often gets lost here is that in either scenario, jobs are going to go. It's just in the best case scenario, they're being created faster than they're being destroyed. So net, we have new jobs, but actually most of the jobs we're doing today are going to go. Oxford University estimates that there's a 48% chance that the profession of computer programming is going to go to the AIs in the next 1 to 2 decades. So we have to think, what are all these computer programmers going to be doing? We think about lorry drivers, we think about people who answer the phone in call centres. We imagine that their jobs might go to the machines relatively quickly. But software engineering seems to be a safe bet. Even people today are being advised to move into that. But I see not too far down the road, there's going to be a lot of out-of-work software engineers. My son suggests that I think about a second career as a freelance Dungeons and Dragons games master, and it's maybe not a bad idea. Now, we don't need to look all the way back to ancient skulls or medieval technology to see this. If you work in IT, you've seen this type of thing happening before. Periodically, we have to reskill, the paradigms shift, and everybody has to learn the new ways. The classic really is centralised versus distributed. In the 1950s, we had massive mainframes that would take up an entire room and people would connect to them with dumb terminals. But by the 1990s, we'd shifted a lot of this computation onto people's desks. So proper distributed applications could be written where the computation was spread around the network. By the 2010s, we'd collected all this computation again together, we'd packed it into huge warehouses full of computers which we called data centres, and people were connecting to these using fairly lightweight devices, reminiscent of the terminals, but now we called them mobile phones and smartphones. And the next technology is actually already on the horizon. So that's edge computing. It's sometimes called fog networking, bringing the computation, bringing the hardware back onto the premises, out of the cloud, so that it can be close to the user and close to the Internet of Things devices that are creating all the data. As a short aside, I did read recently that Microsoft is selling Office 365 to reseller customers, where they can install it on their own data center, something like Office 365 on a CD, and then it can be resold to their customers. This happens in China, it also happens in Germany for regulatory reasons. But will it really be a surprise when in a couple of years' time, with great fanfare, Microsoft announces Office 365 Edge, and we all port our applications back out of the cloud, back on-prem? So I've learnt from my mistakes. I'm pretty sure I can repeat them exactly, or at the very least port them to a new platform. Up until 2019, we've managed to keep ahead. We've managed to sprint from one extreme to the other. But I work in IT, and honestly, to me, it feels like the duration of one of these technological hype cycles has already dropped below the length of an average infrastructure project. So this may just simply sound crazy. Technology can't continue speeding up because we can't keep up anymore. However, this is a trend that's been building for a very long time, and if any of you have tried to time the stock market, you'll know that that can be very difficult. And if we think about it, what we're talking about here is a 4 million year technological bull run. And I don't feel confident to time the end of this or time the peak of this market. So we have to then assume that this will carry on. And if it does carry on, how can that be when the people have been left behind? Well, the elephant in the room is obviously artificial intelligence. Over the last 60 years, software engineering has remained pretty much the same. Again, as Uncle Bob said, assignment statements, if statements, and while loops. But if software is pretty much the same, the hardware is several trillion times more powerful. And even running 1960s, 1970s neural networks on today's massive hardware you get very organic results. You get very smart machines. People often like to deride artificial intelligence. People claim that computers are just zeros and ones, so they'll never be creative. But what we've seen over the years is that one at a time these tasks fall to the machines, and then in retrospect we claim that they were always obvious and they were always routine and they were going to fall eventually anyway. So I think we're only comfortable if AI is somewhere in the future. But remember, with exponential technology, the future is much closer than it seems, and AI is now getting better very fast. Current predictions are that by 2030, $1,000 will buy you the hardware equivalent of a human brain. And then by 2060, that same $1,000 will buy you the equivalent of an entire planet's computation. And we don't even have to wait until 2030. As the prices continue to drop, we're going to be using AI more and more to create software. So Facebook already has a AI module that it calls SapFix that can scan the code, it can identify bugs, it can suggest tests and even suggest patches to the programmers so that they can incorporate them into their programs. And as the price drops, they're going to be putting these things together and creating whole departments out of them. I think pretty soon we're going to see entirely synthetic Scrum teams. So like a million electric monkeys banging away on typewriters, the AI will produce very scrappy code, but other AIs will test it and optimize it. AI modules will be writing the documentation, then it will go around for another iteration, and eventually a human will get involved. Unfortunately, it looks like most of the human coders are going to be fired in this scenario. So we'll be packing these scrums into black boxes. Human product managers will be requesting features. They'll talk to the digital scrum master or the digital product owner. The AI agents will interpret the requirements. They'll run away, a few thousand sprints, each lasting a few milliseconds, and then out will pop an application. The trouble is with the black box, you don't really know what's going on inside it. And like today with deep learning algorithms, we don't really understand why the computers are doing what they're doing. We're happy if it works, and then we're puzzled when it doesn't. One great example of this was an algorithm designed to spot the difference between wolves and dogs. And the algorithm was very accurate, it was doing very well, but it was always making mistakes with huskies. And the researchers couldn't really work out why. So they had to go very deep into the code, and they found that the algorithm wasn't actually looking at the dogs themselves, it was looking at the background. All of the training data had wolves standing in the snow, and so the AI had learnt that snow equaled wolf. And so the husky, also standing in the snow, was clearly a wolf. And now this is the problem, because 95% of the time just aren't good enough when you're talking about flying a plane or driving a car. It's not enough when your Tesla is right most of the time, when just one time it mistakes a swimming pool for a parking space. Initially, this is going to be the big software vendors deploying synthetic scrums to work with human coders on their products. But soon after that, every enterprise will have their own virtual scrums, and no two pieces of code will look the same. So the conference actually focused on DevOps, which is development and operations. So I wanted to talk a bit about the operations side of things. Today, an advanced architecture would be something like what I've got here. It would be a mobile device with the back end deployed into the cloud. Most of the heavy work will be done in the cloud by the big server farms, and a small amount will be done locally on the device to keep a nice responsive user experience for the end user. If it's an advanced architecture, it'll be using some sort of containerization to aid with deployment, and also to spin up and spin down again new instances as required by the load of the users. But in the future, with edge computing, otherwise known as fog networking, every smart device has got computation on board, and there are no longer any dumb devices. So the programs will have much more flexibility about where they deploy themselves. They can select from the local Wi-Fi hotspot or from the server room in the company, or they can run pieces on the cloud. And as these are going to be smart black box programs constantly evolving, constantly rewriting themselves, this is going to be a very challenging environment for us to try and control deployment. So more likely we're going to have to move the operations engineers into the synthetic Scrum team. And there, of course, I'm talking about synthetic operations engineers. And now the programs can rewrite themselves, they can request resources from their environment, they can spawn copies, and you'll have the fog network of the edge computing reflected in the topology of the applications that are running on it. Swarms of applications deploying themselves as foglets. So humans will not be developing or operating the applications of tomorrow. We also won't be driving lorries, building cars, underwriting insurance, analysing credit, answering phones or flipping burgers. So what are we all going to be doing? Well, I think one answer to that is that as the cost of software continues to drop, we're going to just be writing a whole lot more of it. I think the constant is going to be that people will want things, and as with supply and demand, if the demand remains constant but the cost of the product goes way down, then we're just going to be shipping a whole lot more of it. But in order to accommodate this massive growth in the number of products that we're shifting, we have to adopt some new methodologies. Here is interesting because as technology has advanced, it's always allowed us to update our methodologies in order to become more efficient and deliver more. Way back in the beginning of the computer age, programs were written in mysterious runes by wizard-like engineers. Everything was very ad hoc, everything was very one-off. But as the tools improved, in the same way that advanced tooling had allowed cars to be produced on production lines, we could standardize the process of software development, and we moved into the linear age, and this is what we called waterfall in software development. And then more recently, we've got even more advanced technologies helping us write the code, and we're able to push out updates much quicker. This is the adaptive era, sometimes called the Agile approach. And there we ship minimal viable products full of bugs, but we forward fix, pushing updates out to the user very regularly until we have a product that they can actually use. Going forward, when the cost of writing software drops to be virtually zero, the roadblock is actually going to be coming up with new ideas. The same thing happened in hardware. As processors got faster and faster, they were spending most of their time just waiting for the user to do something. So a new approach called speculative execution was created, where the processor would be executing both branches of an if statement on the off chance that the user would eventually follow one of those paths through the program. So basically it was doing its homework in advance so it could just whip it out when needed. And I think that's what we're going to need to do going forward. So the speculative methodology will be coming up with thousands of crazy ideas, executing them with these synthetic Scrum teams, putting them in front of customers, and every now and again, if we're lucky, one of them might turn out to be the next big thing. So putting it all together, pretty soon software is going to be writing itself, it's going to be deploying itself, it will evolve, it will grow, it will spread into new habitats, and our job will be to make the high-level decisions about what we want, and then to make the environments available that the programs can grow into. So for me, the future of IT actually sounds less like software engineering and more like gardening. But as with gardening, if we're talking about evolving black box code, don't be surprised if the major challenge is keeping out the weeds. So this is just one of the aspects of how technology is going to affect us. This is how it's going to change the way we write software and deploy software. But as somebody said on Reddit recently, the 2020s, they're going to be weird. And I think that's the major lesson. Things are going to get very strange because technology is continuing to move faster and faster, and we haven't even started to see the effect of AI or quantum computing or any combination of the two. I hope you enjoyed that. If you want to take any of these ideas further, feel free to check out my science fiction. I write near-future, techno-optimistic sci-fi adventure. And by the way, I used to think that Toby Weston was a very unusual name, but it turns out there's at least 2 other Toby Westons out there writing books. So I'm the Toby Weston writing the science fiction series Singularity's Children. Great, so for more, check out my website, tobyweston.net, or stay tuned for my next video.